Alright, hey ladies and gentlemen, I'm going to try to record this even though I'm with the Breakazoids and it's a little noisy in here. So hopefully you can hear me as I go through this. Okay, so here's the second law, and here's what this would look like. So as we have problems that are like 10 to the 4th times 6 to the 4th. We would multiply the bases and keep the exponent, so we'd get 6 times 10, which is 60 to the 4th. Okay, the second one I'm going to look at is if there are variables, like n to the 5th times z to the 5th. Well, again, keep the bases, like n times z, and it's all to the 5th. Okay, last one we're going to look at is if we have something like 7 t to the 9th times 3 g to the 9th. Okay, so if you need to, remember, you could write these out. You could always write them out. All right, so if we write these out, it's really 7 times 3. So those are the numbers we're multiplying, 7 times 3. The t and g are going to stay the same. So 7 times 3 is 21. And both t and g are to the 9th. So t, g to the 9th. Great music. Okay, moving on. Okay, so looking at this example. Okay, so first I'm going to just do like a basic one. Okay, so the basic level. I'm going to do it with exponent or with variables though, because there's a lot of harder ones on this level. So if we have r to the 10th over r to the 2nd. Okay, well that's equal to, and if you need to, write it out. R, 2, 3, 4, 5, 6, 7, 8, 9, 10 over 2 of them. 1, 2. Okay, boom. Cross those out. Cross those out, and I'm left with 8 r's. R to the 8th. Okay, looking at a second one. Let's look at one where we're actually dividing. So if we've got 20 r to the 10th. Oh, I don't want that. I don't want another r to the 10th. Let's do a different one. So let's look at 27 x to the 3rd over, let's just do this a little differently, 9x. Okay, so, hey, remember, this is like a division problem of these numbers dividing, and we're going to subtract those exponents. What do you see? What is there if you don't see it? There's a 1 on that x, okay? If you don't see anything, there is a 1. So 27 divided by 9 is 3. And we've got x to the 3 minus 1. Okay, well that's 3x to the 2nd. You can feel free to put more difficult problems on here too. I'm going to put one that's even more complicated. So let's say we've got... Okay, I found one in here that I want to use. And it's a variation on a problem in the packet. But let's say we had exponents. X to the 5th times x to the 3rd over x to the 2nd. Okay, well... First, I'm going to do this part on the top. Okay, so in order to do that part, remember, I'm going to add those exponents. So that's like x to the 5 plus 3, which is 8, over x to the 2nd. Now I can subtract those. So 8 minus 2 is x to the 6th. Okay, if you want to put some more difficult problems on there, feel free. We've had some on our worksheets. So take a look at those as I roll on. Okay, looking at this next one. So here's the next rule. Anything to the 0 is 1. So again, I'm going to look at some problems that are, pretty straightforward and then a little bit more complicated. Okay, like z to the 0. Put this as 1. Equals 1. That's pretty easy. But when you get to one that's like 2 f to the 0, well, remember, this is what we did in class. The thing with the 0 is this. So only that becomes 1. So we've got 2 times 1, which is 2. Okay, again, sorry about this extra noise. Working through with the Breakazoids. Okay, how about one that looks like this? So since we've got some extra room, let's say we have, this one seemed to cause a lot of problems. 3 times 10 to the 0. Well, anything to the 0 is 1. So this whole thing has a 0 exponent. So it means this whole thing is just 1. I'm digging this music. Okay. Ooh, how about one like this? B to the 5th times b to the negative 5th. Remember, first we're going to add those exponents. It's like b to the 5 plus negative 5. That's b to the 0, which is 1. Okay, rolling on. Okay, which law is this? Oh, this is our good buddy power to power. Okay, so looking at some power to powers, and we can look at some basic ones, like t to the 3rd to the 5th. So remember what I did in class. I distributed. Okay, so this is like t to the 15. 5 times 3 is 15. Okay, the only time it gets complicated is when we have multiple things in those parentheses. So like 7 e to the 4th squared. Okay, so remember, if we don't see an exponent, there is a 1, and we're going to distribute 2 to the 1, 2 to the 4. Okay, so we'd have 7 to the 2nd e to the 4 times 2, which is 8. Okay, some teachers might want you to write that out as 49 e to the 8th. Okay, just know that some teachers might not want you to have numbers and exponents either. Okay, one that's a bit more complicated. All right, so 5 m n to the 3rd all to the 5th. So again, if we don't see an exponent, there's a 1 there, there's a 1 there, and I'm going to distribute through. Okay, if I do that, I've got 5 to the 5th, m to the 5th, and n, well, this is 5 times 3, that's 15. Again, some teachers might want you to change this part into a whole number, but we're going to leave that for now. Okay, last one we're going to look at, 4. Ooh, this is a challenging one. So let's say we have x to the 13 over 9 all to the 4th. Okay, well, we've got parentheses or brackets, so I'm going to do what's in here first. Oops, that's not what it's supposed to be. Sorry, it's supposed to be x to the 9th. Ha! Okay, so subtract those exponents. First, what's in there? So that's division. Subtract those exponents. And that gives us x. The 13 minus 9 is 4, all to the 4th. Okay, so now I'm going to distribute that 4 exponent and get x to the 16. Okay, again, pause, write down whenever you need. I'm going to go on to our negatives. Oh, that's sloppy. Sorry about that. Okay, so negative exponents. This is the really, really challenging stuff. So we'll write down a couple like just very basic ones. Okay, so let's say you have m to the negative 5. Remember what I did in class. I'm going to circle it and say, okay, being bad, it's going to move down, which means we have 1 over m to the 5. It becomes positive in the denominator. Z to the negative 3. Okay, circle it. It all moves down. We get 1 over z to the 3rd. Remember, when it moves, it changes signs. Oh my gosh, that's distracting. Sorry about that. Okay, 2x to the 4th. Okay, what thing has, x to the negative 4th. What thing has the negative exponent? Just this is moving down. Means the 2 stays where it is, which is on top. 2 over x to the 4th. Oh. Okay, let's look at one where the negative is in the denominator. Oh, sorry about this. I realized that you guys missed part of that recording. So I just want you to check over this, see these ones that I put on here, and double check, see if you have any questions. Use this to study from. This is going to be the guide tomorrow. I'm going to be checking it for points, and I hope you have a great evening. Thank you.